Now that we know how the first derivative affects the graph of a function, we're ready to look at how the second derivative affects the graph of a function. The second derivative gives us information about what we're going to call the concavity, which is really the direction the graph opens. We'll say the graph is concave up when it opens up, like an x squared graph. And the graph is concave up when the second derivative is positive. I like to think about concave up, looks like a smiley face, because the derivative is positive. Contrast that when the graph is concave down. When the graph is concave down, it's an upside down smiley face, a frowny face, because the second derivative is negative. And those points switch between concave up and concave down. Let's say I've got an up, and then it's going to switch into a down. Or maybe I've got a down, and it's going to switch to an up. That switch point, where it switches between frowny face and smiley face, concave up and concave down, the second derivative between positive and negative, that's called an inflection point. And that is where the second derivative is 0. So let's take a look at an example where we look at these inflection points. It's really the point of diminishing return. If you've heard that phrase, the point of diminishing returns, that is the inflection point where the second derivative is 0. Technically, it could also be undefined. But for our class, we won't spend a lot of time on that case. The inflection point is where there could be a change in concavity. So in our prior video, we took a look at the example f of x is equal to negative 2x cubed minus 3x squared plus 36x plus 17. And we found the first derivative to help us with the increasing and decreasing points to identify those critical points, and got negative 6x squared minus 6x plus 36. Now that we know about increasing and decreasing points, we're going to go to the second derivative, which in this case is going to be negative 12x minus 6. And when we set the second derivative equal to 0, that will help us find the inflection points. If I add 6 to both sides, negative 12x equals 6, and divide both sides by negative 12, and x is equal to negative 1/2, that is going to be my inflection point, the point of diminishing returns. It is where the concavity might change. So if that's where the concavity might change, let's look at determining the concavity. And just like we did with the first derivative, we're going to draw a little number line. We're going to put all of our inflection points on it, and we're going to decide if it's concave up or down, to the left and to the right. And the way we're going to do that, just like before, we'll take that second derivative equation, the negative 12x minus 6, and look at the regions to the left and to the right to decide if it's positive or negative. So when we are less than negative 1/2, what happens? And when we are greater than 1/2, what happens? And again, I only care about the sign. So if I think about a number smaller than negative 1/2, like negative 100, if I took negative 100 and I multiplied it by negative 12, we get a negative times a negative, which is some positive, very large. And when we subtract 6, it's still going to be positive. which means when we're less than negative 1/2, the second derivative is positive, so we have it concave up. So it's going to look like an x squared, a smiley face, a positive concave up graph. When we're greater than negative 1/2, that should be a negative. We keep the negative. When we're greater than negative 1/2, maybe we'll take the number 0. Negative 12 times 0 is 0. Minus 6 is a negative. Because we're negative, now we're concave down. It's a frowny face in that region. So if I were to put it in interval notation, knowing we have negative infinity on the left and positive infinity on the right, we are concave up from negative infinity to negative 1/2, and we are concave down from negative 1/2 to infinity, which is consistent with what we expected the graph to do. Remember, we said it was decreasing, increasing, and then decreasing. We found the critical points, you remember from our prior video, were at negative 3 and 2, were that local minimum and maximum. And now we know the additional point of negative 1/2 is when it's going to split between concave up and concave down. The curve is going the other direction after that inflection point. Again, I want to look at what's happening with the saddle points. If we had a saddle point in our graph. In our prior video, we looked at a graph that came up, leveled off, came up, and then bent and came back down. It turns out that you're going to get 2 inflection points on this graph. It turns out that that saddle point is also going to be an inflection point. We'll say that was at 1. We said the maximum was 3, so maybe that inflection point's at 2. And you'll notice that to the left of that first inflection point at 1, it's curved like a frowny face, half of a frowny face. It starts out concave down. So if I were to draw my little sine graph here, we said the inflection points were at 1 and 2. It starts out bending down. Then between 1 and 2, we see it's concave up. It is shaped like a smiley face, or at least the right side of a smiley face. So between 1 and 2, it's going to be concave up. But then you notice after 2, it's shaped like a frowny face. It is rotating down. It is going to be concave down afterwards. So if I put this in interval notation, we would say, with negative infinity on the left and infinity on the right, this one is concave down from negative infinity to 1, and then again from 2 to infinity. And it is concave up only between 1 and 2. So the first derivative of the function tells us if the graph is increasing or decreasing, and where those critical points are, those mins and maxes. The second derivative tells us if it's concave up or concave down, and what those inflection points are, where the concavity changes, that point of diminishing returns. It's your turn to practice some of these on the assignment. Take a look at them and let your instructor know if you have any questions.